Okay, so a quick explanation of what is going on in our scene. Say we have two vectors. A would be the base and B would be the goal. So this point would represent a particle at the base position. This point would represent a particle at the goal position. What we need to find out is a velocity vector v that basically drives the particle from the base towards the goal. So what we can do in order to get to this vector, right, is we can make the difference. So the way to do that is by inverting A, so this is the inverse of A, adding B to it, so we're adding B to it, and then the resultant vector of this operation is V. So if I just make this available, V would be equal to the inverted vector of A plus B, or we would have B minus A. But these are vectors. So what we will have to do in Houdini now, if we switch back to Houdini, is at the moment we have access to the position of the base, but we do not know the position of the grid yet. We have the position of the grid in sub level, but not yet on pop level. So one of the things I will do is I will add an attribute to this. I'm just going to say attribute, and I'm going to give this attribute a name. I'm going to call this goal pos, goal position, and it's going to be a vector. And basically I'm going to type in an expression which will reference our null object on the sub level. So first of all, I'm going to get the position, so I'm going to go up to my sub level. I'm going to go not the base but the goal. Yeah, so I'm basically going up to the sub level. I'm going to get the null goal object, right? And what do I need of it? For every point number, so I'm going to type in $pt. For every point number I will be needing its position, so p, and since position is an array of 3 floats, it's really a vector. At this point I just want the first value in the first value of my goal pos, so that this vector corresponds, right? And then I'm going to copy this and just paste this into the next field, change the last part to 1, so at the moment this will take the second, even though this is 1 because the index started at 0, this will take the second part of the vector p of the current point of the goal object, right? So once more for the final one, and this will basically take the z component. So we've got the x and the y, and this is the z component, right? So if I just name this attribute goal pos, then we can start to use this, right? Okay, so one of the things that I will do now is create a new VOP pop. So I'm going to append a VOP pop, as such, VOP pop, and I'm gonna dive inside of it. Right, let's give ourselves a bit more space. So I'm going to create some global variables as inputs, right? This will give me access to P, which is basically at the moment the base position, right? And the output P will have to become sort of the, or rather the output velocity will have to become the resultant vector that we sort of that I showed on the whiteboard. So first of all, if this would be A, yeah, if P, you know, like on the whiteboard, if this is A, what we will be doing is we're going to invert this. So I'm going to now create minus A. So an easy way to go about doing that is just say by multiply constant, right? And this is, instead of 1D float, this has to be a vector, 3D vector, because we're dealing with a position. And multiply this with minus 1. Right. On top of that, we need an addition, right? We need to add the new one. We need to add B to it. We need to add B. Now B, we just created B, and we called it goal pos as an attribute on the pop level. So basically, B is stored inside of goal pos over there, right? Because we're querying the goal. So in order to get to the B parameter, I could say over there, get my goal pos. Go get that, right? And again, this is a vector. So a vector, and let's call this as well goal pos. and just copy paste it over there. And I'm going to add this in with my previous one. So basically as such. So at the moment I'm getting my current position, and I'm sort of inverting it, and I'm adding it to my new one, and I'm going to output this into my velocity. I don't have any previous parameters built in, so this might just be a little bit rough, right? But as you can see, it is going towards the goal object, right? And the goal object is moving as well, so you can kind of see this updating. Now we want to have a little bit more control over this, so what I want to do is I'm going to take the previous velocity and say that we want to have a little bit of noise fields, force fields going on in there as well. So what I can do is multiply this, or rather add this first. The previous velocity, I'm going to add that with the new velocity, and I'm going to output the sum inside there. One more thing that I want to do, since goal position is an attribute that I created and that I query from above, I'm going to turn on invisible, so it is no longer available over there to tweak. So a user cannot sort of mess it up. So let's just make this invisible. Okay, one of the things that I want to do as well is with the previous velocity, I kind of want to say how much of this new velocity, how strong do I want my goal to be? So I can sort of build in a goal strength. So I'm going to add a multiply, right? I'm going to create a new parameter. These will be user parameters, so a float will be fine, and I'm going to call this one goal strength. Goal strength. As such. The default value, I'm going to set my default value to something like 0.1, because if we set it too strong, it's going to overshoot its target, and the results will be a little bit too strong. So I'm going to convert this float to a vector so that we can start multiplying it with this addition. There we go. And then basically multiply this sum with this new parameter. This is just going to be a multiplier, so it's just going to soften the influence of the goal strength in a way. And this product will be plugged into the addition as well. Okay. So now we have a parameter. If I rewind this. Now we have a parameter over there, the goal strength. If I just turn this all the way to 0, right, then there is no goal. There is nothing of goal anymore, so basically nothing is moving. If I start to move this up just a little bit, you'll start to see up, and it shoots, and it kind of overshoots, and it keeps on going. The particles keep on going because there is no drag at all in the system. Their velocity never really slows down. They just keep on gaining and gaining more. So I'm going to build in a little bit of drag as well. Okay, the way to go about doing that is we could say the same process as we did over there with this multiply and the float and the goal strength. I'm just going to copy this entire network and paste it again. Paste it there. But instead of having the addition as an input for my multiply, I'm going to get the final output and plug that in there. And this will be basically sort of a drag multiplier. So the result of whatever the forces are, so the previous velocity and the new velocity based upon the goal, the goal velocity and the previous velocity, can now be multiplied, can now be slowed down on their own with a drag. So we can say drag and once more drag. And I'm going to give this a default value of something like 0.95, so that basically over every frame there is 5% lost, and it maintains 95% of its velocity. And let's plug that in there, right? Let's rewind and let's have a look. So as you can see, the particles overshoot slightly, but then slow down. So this is already a lot better. If we want them to slow down even more, or just don't overshoot, if they, like really slowly go towards their target, right? Then basically the drag will be set lower, so they only have 70% of their initial velocity of their velocity going. Alright, let's say we add some forces to this now. So at the moment we've got the goal strength going, and over there we've got the complete velocity. One of the other things that I want to add now is, what if there is a noise field or any other kind of turbulence parameter inside of pops influencing this velocity, this previous velocity, and we really want this one to have a bigger influence than whatever the previous one is, then we can actually add this new network, this goal network. Again, the same thing, we can add it to the old velocity. So let's do that once more. And I'm just going to copy this guy and paste it in there. So what just happened is the old velocity, right, is now plugged into a new multiply, into a new strength. But instead of goal strength, I'm just going to call this, you could call this force strength or particle strength, or I mean anything besides the goal. So let's just copy this. Okay, so these are basically 3 parameters that the user has to play with and to manipulate. So let's have a look. I am just going to give it a default value as well. So normally, let's say we want the full force, so it's just going to be a full-on multiplier. But I'll show you the result in a bit of what this can do. So again, same thing. That's fine. And they are, they're keeping up with the moving shape. One of the other things as well now that I wanted to do is add some forces to this. So I'm just going to add a force. I'm not really going to add any of this force directional. I'm just going to add a noise force. So let's say a small frequency, something like 0.3. This will do. What I can do there is in the amplitude, I'm going to give it a little bit of amplitude as well, so something like this, 1.3, and an offset. So I'm going to use $t again, and let's say times 0.5. And I'm going to copy this parameter and paste it in all the offset values, so that basically it is calculated once and then just referenced straight on. So paste copied relative reference, paste copied relative reference. So all of them will be the same, right? And I've got this moving force going onto it now. So there should be a little bit of force on top of that. I'm going to temporarily disable my mountain, right, so that we can have a better idea of the exact movement, what's going on there. Well, at the moment, as you can see, they're moving about, like a little bit, and we might not want them to. So in this case, we can just adjust the vol pop, so like I just say with the particle strength, and we can increase the goal strength and decrease the previous particle strength, right? And as you can see now, the influence of the noise or of the forces are a lot less. It's like it's reduced hugely, and the goal strength is sort of taking over, right? Okay. One of the things that is kind of nice to sort of tie this in with is, say that we tie this in with the life of the particle. So we could add an expression to this and just say fit. So I'm going to use $life in there. And I want to have it range between 0 and 0.2, 0 to 1, right? So what this does is basically this will multiply whatever the amplitude is with a value. Life is generally a parameter that goes between 0 and 1. It is normalized. It's a particle attribute. And I wanted this multiplier to basically go from 0 to 1 over the range of the life of 0 to 0.2. So basically over 20% of the particle's life, this force will start to increase. Yeah? Now let's do the same, but let's sort of do the opposite. And let's have the force decrease over the life as well. So as it reaches the end of the particle's lifespan rather, then I want this one to go to 0. So it starts at 1, sorry, and it goes to 0. So if I just bring up an expression editor on this one, so you can have a better idea. So this one will increase, so as you can see over there, from 0 to 1 over 20% of the lifespan, and this one will basically go from 1 to 0 over, this is 50% of the lifespan, but it's kind of, you know, like it starts at 30 and it should end at 80%. So at 80% of the particle's life, the force is completely 0, so there's no strength in that force anymore. Alright, accept this.